In Robots of the Lost Ark, we proposed 3 novel dynamic manipulation tasks with fixed endpoint cables to vault over obstacles, knock objects off a base, and weave between obstacles. The project was inspired by one of our favorite movies, Indiana Jones, Raiders of the Lost Ark. This paper makes 4 contributions. First, 3 novel dynamic cable manipulation tasks for vaulting, knocking, and weaving. Second, an algorithm for learning a dynamic manipulation policy for cables using a parameterized high-speed trajectory. Third, a simulation platform to experiment with novel tasks and policy learning. Fourth, physical experiments evaluating the policies with the UR5 robot on 5 different cables.
Here are some key related works of our paper. We believe that our paper is the first one to use imitation learning techniques to teach a robot to complete dynamic cable manipulation tasks. We assume that one end of the cable is attached to a wall and the other is held by a robot gripper. We also assume that the image is taken from a camera slightly above the robot arm. In this problem, we consider the input as an image of a scene with object and target, and the output is a trajectory of a robot arm that is within joint position, velocity, and acceleration limits. This paper presents a self-supervised learning pipeline that enables the UR5 robot to learn to perform these 3 tasks. The pipeline trains a deep convolutional neural network that takes as input of an image observation of the scene, and it computes a 3D apex point for the robot arm, which then will be fed into a QP solver to find the shortest and fastest feasible trajectory that minimizes the jerk of the joints within joint limits. We perform physical experiments on 5 physical cables with different thickness and mass. To experiment with the training algorithms and warm start the training in a physical environment, we evaluate 60 apex points in simulation and select the one with the highest success rate.
Here we show the resetting action before executing any trajectory by pulling the rope taut.
We compare performance measured as success rate of task completion with 2 baselines in which a human chooses the apex point.
In our physical experiments, we run the trained policies for the 3 tasks that were trained on the 18-gauge orange cable on other cables without retraining. The vaulting policy was trained using 180 physical trials. The knocking policy was trained using 180 physical trials. And the weaving policy was trained using 100 physical trials. In our evaluation process, we run 20 trials for each cable type for each task respectively.
Thank you for watching.